Welcome to Blismos Academy. Welcome to Data Warehouse course on our Blismos Academy's YouTube channel. We hope this content helps you to get the basics and advance your career to the next level. You may be wondering, where do I need to start? Before you start, you need to complete some of the important essential topics. And there, you need to have a knowledge of SQL or SQL. You need to have a knowledge of RDBMS. You may be thinking, where do I learn this? Don't worry, we have it covered for you. We have RDBMS and also SQL tutorial as a part of our Blismos Academy. Please go through both of them before you get started with the data warehouse course. Important topics covered as a part of this course are how transactional processing is different from the analytical processing, what is data warehouse, how OLAP is different from OLTP, introduction to the ETL, transforming data and loading through ETL, architecture of data warehouse, data marts, dimension and fact tables, schema, slowly changing dimensions, and ETL tools. You can watch the complete video to enjoy the benefits of the course. However, wherever you know the contents, please skip them as they apply. Thank you for choosing us. We are really excited to guide you through data warehouse journey.
Transactional and analytical processing. Let us take an example here. We have a company. Within that company, there are two team members working. One of the team member being Vivek, another one being Monica. Vivek is in order management support. On the other hand, Monica is a data analyst. Being in the order management support, Vivek is responsible for tracking and delivering the orders. Monica is responsible for tracking and monitoring revenues. What happens is, Vivek is in a order management support. On the working day, he receives a call, 10 deliveries in Bangalore are delayed. He immediately calls and does some analysis and finds out why is that all these orders are delayed. He finds out that courier company through which the orders need to be delivered had a computer outage. So what he does is he immediately assigns the orders to another courier company in the region and routes all these 10 orders through other courier company, and he ensures that those orders are delivered. He faces one more situation. 5 of the customers want to ship orders to a different addresses in the regions managed by him. Again, our Vivek will go and updates the addresses on the shipments and he reroutes them. Monica is a data analyst. On one of the day, Monica's manager wants an update on what are the revenues of the last month. What Monica does is she will get into a system and starts analyzing. But she finds out for some reason last month revenues are unusually slow. There is a dip in the revenues. What she does is she pulls out the data for last 5 years and sees in this particular month was there any seasonal effect in the previous 5 years as well. She analyzes that, she submits the reports to her manager. On the other occasion, Monica's manager asks her, can you find out whether the TV ads we have run last year were successful or not? What she does is she checks how many customers have signed up, or if there is any jump in the number of signups when the campaigns were run. She analyzes it and she submits the report to her manager. We have seen 4 situations here. 2 are managed by Vivek. Another two are handled by Monica. Is there any difference between situations handled by Vivek and tasks handled by Monica? Yes, there is a difference. Situations handled by Vivek are of a transactional nature. Tasks handled by Monica are of a analytical nature. Day in and out, in the current scenario, any company would face both transactional scenarios and analytical scenarios. That is the reason it's very important to know how the transactional processing differs from analytical processing. We'll try to understand the differences between transactional processing and analytical processing. Transactional processing analyzes the individual entries. If you remember, Vivek handled not more than 10 records per time. If you speak in terms of records in database, he at the most updated around 10 records. On the other hand, Monica analyzed last 5 years data, isn't it? She analyzed last 5 years data. In the analytical processing, we analyze large batches of the data. In transactional processing, we access the recent data, maybe from last few hours or days. On the other hand, in analytical processing, we access the data which is older, maybe in months or even years. In transactional processing, we usually take care of updating the data also. As you know, in the first example, Vivek updated the courier company through which the order need to be routed. In the second case, he updated the address for rerouting the orders. On the other hand, mostly in analytical processing, we read the data rather than updates. If you see, Monica analyzed the data of last 5 years in the first case and analyzed the data for a couple of months, whether the signups have happened or not when the TV ads were run. Here in case of transactional data, there is a real-time access. But on the other hand, in analytical processing, we have long running jobs because the amount of data we are handling in analytical processing is more. That is the reason to fetch the data, to analyze the data, we would have long running jobs. Usually, in case of transactional processing, we would have a single data source. On the other hand, in analytical processing, we would have multiple data sources. For example, to check why the revenues were low in the current month, she had to check data from previous years from the multiple systems. I hope you understand how transactional processing is different from analytical processing. Now, having understood what is transactional and analytical processing, we know that the objective of a transactional processing is different from objective of a analytical processing. Now, if we are managing the small amount of data, both of these objectives can be achieved through the same database system because the amount of data we're handling is less. For a small data, we'll have a single machine with a backup. Mostly, we would have a structured or well-defined data. And also, we usually access the individual records. And we would have not done any replication, and we'll have mostly data available instantaneously. In the small amount of data, usually different tables would store the data from different sources. On the other hand, when we have huge amount of data, it's very difficult to meet all these requirements with the same data system. When I say all the requirements of the transactional processing and analytical processing cannot be achieved in the same database system in case of big data. Why is that? Because data is distributed on a cluster with a multiple machines. Along with the structured data, we'll have semi-structured data and unstructured data also stored as a part of the big data. We'll not be able to access data randomly. Data is replicated. As we have already seen in case of HDFS, data is replicated 3 times. When the data is replicated, whatever the update you are making, propagation of that would definitely take time. Different sources may have different unknown formats. We're not talking about only one source here. We're talking about multiple source, multiple formats. Because different sources are there, it may have many unknown formats which are not known. The same infrastructure definitely cannot support both transactional and analytical processing in case of big data. So for a transactional processing, we would have a traditional RDBMS. For analytical processing, we have system called data warehouses. When I say warehouse, are you thinking about a big building where multiple products are stacked? No, we are not talking about that. We are talking about a data warehouse. But before we venture into that, at a high level, what is data? Data is nothing but a raw facts and figures. But we need something to store the data, right? We have seen we do have multiple RDBMS systems which are very much used to store the data, like Oracle, MySQL, PostgreSQL, multiple RDBMS systems are there. And as a part of our previous video, we understood that the same systems will not be able to store the large amount of data to take strategic decisions. So this is an operational system. These RDBMS systems are for transactional processing. If I want to use the RDBMS systems for analytical processing, will not be able to do so for the large amount of data. That is where data warehouse comes into picture. So what is data warehouse? At a high level, data warehouse is a large store of the data. You'll have a large store of the data. That data is accumulated from wide range of sources, and those sources are within the company. Sometimes we may get the data from outside as well. But why are we doing all this circus? To guide management decisions. So data warehouse, in a simple layman's term, is a large store of data accumulated from wide range of sources within a company used to guide management decisions. Please bear that in mind. We always build the data warehouse to support the management decisions, to guide the management decisions. Data warehouse is very important. Let us understand the data warehouse from other definition. One other important definition is a data warehouse is a subject oriented, integrated, time variant, non-volatile collection of the data used to support the management decisions. That is the data warehouse. Let us dissect this definition and understand bit more. When I say subject oriented, what am I talking here? We understood RDBMS systems are used for the transactional process. Or if you look at any applications, applications are used to support the operational systems. So in most of the industry, data sets are organized around individual applications to support particular operational systems. So these individual data sets have to provide the data for the specific applications to perform specific functions efficiently. On the contrary, in data warehouse is stored by subjects. not by applications. But what are these subjects? What are these business subjects? These subjects are critical for enterprise. For example, in terms of operational applications, let us say we have operational applications. So we can say order processing and consumer loans, customer billing, accounts payable. All these are operation systems. On the other hand, data warehouse subjects are sales. It can be a product, right? So these are the data warehouse subjects. I hope you got the point. Data warehouse is built around the subjects rather than the organization's current processes. Like the subjects can be a sales or a product rather than operations like order processing or consumer loan, etc. Second important thing is data warehouse is integrated. So when you want to take the decisions, you got to get the data from multiple sources. As a part of the data warehouse, we do get the data from heterogeneous sources. When I say heterogeneous, like we may get a data from database, we may get a data from application, we may get a data from files. Within databases or RDBMS systems, we may get a data from MySQL or Oracle. Within applications, it can be order processing systems, it can be consumer loans, it may be claims processing systems. In files, we may get a data from JSON or a CSV file. Like this, we get the data from heterogeneous sources and integrate them and store that in a data warehouse. Data warehouse is time variant. If you look at the operation system, you got to store the current value of the data. For example, banking system. You got to store the current value. What is the balance of a particular customer? Otherwise, if he's trying to withdraw more amount, then it is a problem. So operational systems always need to store the current value. But data warehouse is not meant for the transactional processing. Data warehouse is meant for decision making. It is meant for analysis and decision making. So that is the reason we store the data from last few months, last few years. Here in data warehouse, we will find historical snapshot of the operational data. That way, you can analyze the past, relate the information to the present, and enable the forecast of the future, right? That is the time variant nature of the data in data warehouse. And the last one is data in data warehouse is non-volatile. When you come to the transactional processing, there may be a chance that every second the data may get updated. But that is not the case in data warehouse. It is relatively non-volatile as compared to the operational systems or transactional systems. Wonderful. Just to conclude, data warehouse is a subject-oriented, integrated, time-variant, non-volatile collection of the data used to support management decision-making processes. When I say management decision-making processes, what am I talking here? Some of the decision-making processes like how do you retain the present customer base? How do we increase the customer base by 15% over the next 5 years? How can we gain the market share by 10% in the next 2 years? How do we improve the product quality levels in the top 5 product groups? So for all these kinds of decisions, you need to have a subject oriented, integrated, time variant, non-volatile data stored in data warehouse. If I take you back to 1960s, when the modern day computer started just emerging, how do we used to store the data? We used to store the data either in magnetic tapes. Then we started storing the data in either floppy disks or CD-ROMs or CD disks like that. And then if I ask you a question, now where are we storing the data? We store the data in hard disks. And also there is a new concept called solid state drive. the way we have been storing the data from 1960s until now has drastically changed. That is the first point. The second point is the money what we used to spend to store 1 GB of data earlier has come down drastically in the current age. Over a period of time, the data storage has become economical. From the beginning of the modern day computers, as and when the time passed, the data storage became economical. Then if you peep into the applications, earlier we used to have a single or few applications. But as and when the time progressed, the number of applications in an organization started increasing. And also one more very important thing what happened is emergence of a end user computing, powerful interface and tools. Now, if you remember, around 20 years back, we used to hardly use one or two systems personally. Now, we have so many applications on our mobile itself. As and when time advanced between 1960 towards the current era, the number of end user applications increased drastically. That is a bit on application. Now, if you look at in terms of the data, by considering these two things, like one is the storage has become economical or cheaper. The number of applications being used by organization increased drastically. Number of applications used by the users increased drastically. So what is happening with respect to the data here? Amount of data in organizations increased drastically. And also there is a lot of data being created by the users as well. So we have a data in organization from the multiple applications, and we do have a data from users because users are also using the multiple applications. So we have a data from organization, we have a data from users, and the data can be stored in a very cheap storage. So whatever the data being produced by organization, being produced by users, which is stored in a economical cheap storage, can this data be of any use to a company? Yes. But the data, organizations also have multiple systems. It may have a RDBMS systems, it may have files, it may have applications, and users also producing multiple amount of data. Now that we understood lot of data is there in an organization in a multiple systems, and users are also creating the data, and that can be stored in a cheap storage. While we understood we can make use of this data, there is a need for a system which can bring the data from multiple sources, make the data in a standardized format so that it can be accessed by a relevant people in an organization to take strategic decisions. That is where data warehouse came into picture. All these things like cheap storage, huge amount of data being produced within the company and outside the company, there is a need to bring the data from multiple sources into a standardized format so that we can use the data for the strategic decisions. That led to the development of the data warehouse. When we talk about the history of the data warehouse, we have to talk about the father of data warehouse. And who is that? That is William Inman. William Inman is the first person to hold the conference in data warehouse. He is the first person to write the first book on data warehouse, and he is the first person who offered the classes on data warehouse, and he created the accepted definition of data warehouse, which we have covered in our earlier video. When we talk about the systems which are supporting the business on a day-to-day basis, we do have two types of systems. One is OLTP systems, another one is OLAP systems. Let us understand them one by one. When we talk about the operational systems, which will support the daily business of any organization, they are called as OLTP systems. What they do is they capture and maintain the current transaction data in a database. What is OLTP? OLTP is nothing but online transactional processing. That is what is OLTP is. In OLTP, data processing consists of executing the transactions. Those transactions would occur concurrently. Let us say you have a e-commerce website. There are multiple products available for sale. So multiple people are ordering the products on an e-commerce site, right? That will get updated in database. How is it happening? It is happening very frequently, and the transactions may happen sequentially in all the ways. This whole e-commerce system, which is selling the products and those transactions being updated in database, is an operational system. Just to summarize, OLTP systems supports the transaction oriented applications. It is based on the entity relationship model from the database perspective. Here in OLTP system, the primary objective is data processing, not the data analysis. Let us see what are information system. As the name suggests, they provide the information. These information systems are used for the analysis. They're also called as OLAP systems. So OLAP systems captures and maintains the large amounts of historical data that is aggregated from the OLTP systems and any other sources for analysis and reporting. What is OLAP? OLAP is online analytical processing. Whenever somebody says OLAP, don't get confused. It is online analytical processing systems. OLAP systems are mainly designed for supporting the decision making process in an organization. How are they supporting? Based on the historical point in time, analyzing the data of the past and predicting the future. How are you doing that? By writing the complex queries or using the data mining applications. What is the example for an information system? It is a data warehouse. Each and every organizations should have a data warehouse to get the data from multiple sources and then subject that for transformation and build a data warehouse. By using this standardized data, we can analyze and use the data for taking decisions. Just to summarize, OLAP systems are the tools which provide analysis of the data for business decisions. OLAP systems allow users to analyze database information from multiple database systems. The primary objective of OLAP system is data analysis, but not the data processing. So what is very important is whenever you take any business, we need to carry on with the business by supporting the operational systems. At the same time, it is very important to subject the data for analysis to take the decisions. So we need to separate the operational systems from the information systems. Operational systems are OLTP systems and analytical systems or information systems are OLAP systems. OLTP systems provide immediate record of current business activity. On the other hand, OLAP systems generates and validates the insights from the data which are generated by OLTP systems. As we already indicated, lot of data is produced by OLTP systems. That data is ingested into OLAP systems through extract, transformation, and load. What exactly is this extract, transformation, and load? We'll see that as a part of the next video. But before that, how OLTP is different from OLAP? Though we know it at a high level, let us drill down deep into the differences. First and foremost thing is OLTP systems handle day-to-day operations. On the other hand, OLAP systems are used for a decision support, more of a strategic directions of the company. In terms of purpose, OLTP systems are for transactional processing, but OLAP systems are for reporting and analysis. When we have to design the OLTP systems, we consider the application. It is more of a application oriented. In terms of OLAP, it is subject oriented, like customer, it can be sales, it can be like that. In case of data, OLTP systems would have a current data. OLAP systems would have a historical data dating back to months, years, like that. In terms of method used to create the OLTP systems, we use the RDBMS systems. Here in OLAP, we use the data warehouse. In terms of process, OLTP systems are online transactional systems and OLAP systems are online and data retrieving processes. The size of OLTP systems are in gigabytes. On the other hand, OLAP systems are in terabytes. How about the number of users? Number of users of OLTP systems are thousands, maybe millions also. But on the other hand, OLAP systems will be hundreds or not more than thousands. We understood what is data warehouse. Also, we understood what is the difference between OLTP and OLAP. OLAP systems are nothing but the data warehouse. So, but how do you really build the data warehouse? There should be some process need to be followed to build the data warehouse, right? That is where ETL comes into picture. What is ETL? Let us understand that. The context here is organizations have data. In any organizations, there are multiple sources of the data. The data may be there in different RDBMS systems. The data may be there from different applications. Data may be there in different files. But as a part of the data warehouse, what we want? We want a standard non-redundant data so that can be accessed and subjected for analysis to take decisions. If the data is there in the multiple sources, source 1, source 2, source 3, and can we directly start putting this data into data warehouse? No, it doesn't work that way. So what we need to do is we need to bring all this data to a common platform called staging. So the process of bringing this whole data into a common platform called a staging area is called extraction. Will that suffice to build the data warehouse? Not really. What we need to do further is the data which is extracted to a common area from different sources need to be converted into a standard structure without any duplicates. But this whole process of converting the data in a common area, that is a staging area, into a standard form of the data which can be consumable is called as transformation. So first, what did we do? We extracted and then we transformed this. And then after transforming, we have to load the data into data warehouse. So ETL is a process where you are extracting the data from multiple sources and moving that to a common area called as a staging area. Then subjecting this data to a transformation. After transformation, you are loading the data into a data warehouse. And ETL process is one of the very important process in building the data warehouse. Without ETL process, you will not be able to build the data warehouse. If we talk about the data engineering, it can be a just data engineering with the structured data. It can be a big data engineering or any data engineering. It can be a structured data, unstructured data, or big data. You have to perform the ETL. So ETL is very much a part and partial of any of the data engineering activities. So ETL is very important. ETL is extraction, transformation, and load. Without ETL process, you will not be able to build the data warehouse, right? So ETL is nothing but extraction, transformation, and loading. And ETL is the process which people cannot avoid if they are doing a data engineering. It can be big data engineering, it can be any data engineering for that matter. So let us understand extraction. Extraction. Are we talking about the wonderful honeybees siphoning a nice nectar and building a beehive? No, we are not. Then what are we talking about? We are talking about a extraction process in ETL, which is the central process of building any data warehouse. So what is extraction then? Extraction is nothing but pulling the expected data from different sources into a common area. Please pay attention here. I'm saying pulling the expected data. The source may have different data, but I don't want all the data. I want the expected data which will help us to build the data warehouse. And where are we extracting from? We're extracting from the different sources which are heterogeneous in nature. And after extracting, we are storing that in a common area that happens to be a staging area. So extraction is a process of pulling the expected data from different sources into a common area. But aren't you wondering, why do I need to extract the data? Why can't I directly pull the data and subject that for transformation and load it? Why do we need to extract? There is a important reason for that. So if you see all these sources, these are the RDBMS systems, these are the applications, and these are some files. All these are in a way supporting the operations. They're called as the transactional processing systems. So they are supporting the day-to-day business activities. If you go ahead and start pulling the data based on your will and wish, don't you think it will impact the performance of the systems into the business? Yes, it will. That is the reason you have to extract the data from different sources at the time convenient or at the time when these systems are used less and move that to the common area. The second aspect is it is also difficult to pull and transform and load the data directly into the data warehouse. That is the reason we're extracting the data from different sources into a common area that happens to be a staging area. So just to summarize, extraction is nothing but extracting the data from different sources so that we can use that as a part of the data warehouse. After the extraction, what are we doing? We are transforming the data and loading the data into data warehouse. Then why do we need to extract? The data extractions allows us to consolidate the expected data into a centralized system, that is staging area, so that we can subject that for the transformation and load that into data warehouse. When we're talking about the different disparate heterogeneous systems, within that main systems from which we extract the data are RDBMS systems. So when we talk about the RDBMS systems, are we extracting the data from only one RDBMS system? It depends on the project. It depends on the organization. You may extract the data from SQL Server. You may extract the data from MySQL. You may extract the data from Oracle or PostgreSQL or any other RDBMS systems. In terms of applications, you may have different types of applications in your organization. Some of the, just to give you a notion of application, there are some applications like GPay, Paytm, Flipkart. Within that Flipkart, you may have different applications to run the operational processing. Within Amazon, you may have different applications to run the operations. So we'll extract the data from different applications within the organizations. And in terms of files, will we have only one type of file? No. Depending upon the project, depending upon the organizations, we may have a just a text file. We may have a comma separated file. We may have a Excel file. We may have a JSON file. So extraction process is also very, very important. We can also extract the data from different mainframes like vSAM and also DB2. Even though it looks like a very simple process of getting the data from different systems, this is also important phase of ETL. You can see when we look at the permutation and combination of all these systems and different sources, it is a humongous task itself. Do you know about butterflies? Who doesn't know? Most of the people do like butterflies. If you look at the life cycle of a butterflies, eggs hatch into caterpillar. They eat a lot. After eating for quite some time, they'll sleep in pupa. After some time, beautiful butterflies emerge out of the pupa. What is happening here? Eggs are transformed into beautiful butterflies. Are we here to learn the transformation of eggs into butterflies? No. We are here to learn the transformation in ETL. So what is transformation in ETL? Transformation in ETL is a process of altering the data based on the business rules. Maybe as simple as converting the dollars into rupees. On what we are trying to apply these business rules? We are trying to apply these business rules on the values in the different columns of the tables or the data which is coming from a files. For example, here we have a table. Within that, one of the column happens to be having price in dollars. $2, $3, $4, $10, like that. But for me, requirement is to have all these values in rupees in our data warehouse. So what we'll do is we'll convert this all the values in dollars into rupees. This is one of the very simple example of a transformation. One more way of looking at the transformation is converting the data from one format of the source system into the required format of a destination system. What is this source? What is this destination? When we look at the ETL process, there are different stages involved here. So let us say at the first step, we have sources, then we have staging area, then we have data warehouse, then we have data marts, then we have visualization. What happens is when we move the data from here to here, source systems are the source and staging area is a target. But when we move the data from staging to data warehouse, staging area becomes the source and data warehouse becomes the target or destination. What is happening in the transformation? We're converting the data from one format in the source system. Example being here, the data in a staging can be considered as a data in a source, and that is subjected to transformation and loaded into data warehouse. Just to summarize, the purpose of the data transformation is to convert the extracted data into required usable structured format and deliver it to the destination. Destination here being the data warehouse. Amongst the different stages in ETL, transformation happens to be the complex stage because we need to do multiple conversions, filtering, multiple things. That is the reason this is the most complex part of the DWH. And transformation is applied in the staging layer. Whatever the data which is in the staging layer, in that transformation is applied, then the data is loaded into the data warehouse. We do have different types of transformation. They are basic conversion, integration, filtering, calculations, sorting, and error handling. We understood there are different types of transformation like basic conversion, integration, filtering, calculations, sorting, and error handling. These are the most important types of transformation which can be done in ETL, but there may be other types as well. But we are focusing only on these important types of transformation. What is basic conversion? Basic conversion is very basic. What do I mean by that? Let us take an example here. When we talk about the data, mostly the data would be there, the table or files. Your table has a price in dollars that need to be converted into rupees. That is a basic conversion. And vice versa also. If the data is there in rupees, we want to convert that into dollars. But why do we need to do conversion like dollar to rupees, rupees to dollars? There may be different business scenarios. Assuming that Amazon CEO who sits in Seattle wants to know how the business is happening in India. Will he understand the rupee? No. So if we have to build the warehouse for Amazon in US, you have to convert all the transactions in rupees in India to dollar. There may be another example like you have a date as a part of your column in an Indian format. If you want to convert that into US format, that also can be considered as a basic conversion. Like in India, we say date then month, then year. So in case of years, we'll have a month first, then we have a date, and we have a year. This also can be considered as a basic conversion. So it transforms the data from one form to another. That is the basic conversion. What exactly is the integration? We have already understood integration is nothing but getting the data from multiple sources, bringing that to a common standard format. If you look at this example, we have some 3 columns as a part of our table from a RDBMS source. And we have another 3 columns coming from files. We have another 3 columns coming from some different applications. As a part of the warehouse, I don't need all the 3 columns from here, all the 3 columns from here, all the 3 columns from here. I need only few columns. So what I can do is I can get the employee ID from here. So which is a common across all the 3 tables, and name from here, salary from here, and attendance from here. So I'm integrating the data from different sources before I move that to a warehouse. That is one simple example of integration. What exactly is a filtering? Are you thinking about a filter coffee in India? We're not talking about the filter coffee here. We're talking about filtering the data according to certain business rules. What may be the business rules? Depends on the project. Some of the examples of filtering are, let us say, you want to filter all the transactions below 100 rupees or $2, because you may think that may not add any strategic value when we are taking that data to the data warehouse. That is one example of filtering. One more example is, please filter all the data where the transaction is made by person less than 10-year-old and person more than 90-year-old. That may be one example of the filtering. Calculations. Can you imagine any analysis happening without a calculation? We need to have a calculations. So while trying to move the data from a staging area to data warehouse, it is subject the data for transformation. Transformations include calculations. Calculations like you may want to count the data from different sources and put the count in data warehouse, or you may want to get only the maximum of particular data and move that to the data warehouse, and you may have to take the average and move that to the data warehouse. Sorting also is one of the important type of transformation. Whenever you want to move the data, sort the data based on some business rules, like highest salary to lowest salary, or highest transaction to lowest. So depending upon the requirement, can sort the data before you move that into the data warehouse. Can you imagine any data without errors? You cannot. So you have to handle the errors as well before we move the data into the data warehouse. For example, here we have a column called EMP degree. Here there is nothing here. What do I do with by taking this data? Nothing. So take out that before I move the data into data warehouse. We understood what is extraction. We understood what is transformation. So what we did is we extracted the data from different sources and moved that to staging area. Then we subjected the data to transformation. What do we do next? That data need to be stored somewhere, right? So that is where load comes into picture. We load the data into the end target. The target being here, the data warehouse in this case. So we extract the data from different sources, subject that data for transformation, and then load that into the data warehouse or the end target. For example, now you may load the data from data warehouse to data mart after doing some other aggregation or transformation. So loading is a process of loading the data into the end target. Just to summarize, loading is the final step or ultimate step in the ETL process. You extract, you transfer, and you load. Load is where data is loaded into the data warehouse. So it is a stage where transform data from various sources is loaded into the target. That target can be data warehouse or data mart, depending upon which is the source and which is the target. That is pretty simple, right? We completed extraction, transformation, and loading Before we get into data warehouse architecture, what is an architecture? Architecture is there everywhere. Whether you are building a building or you are trying to build a system. So what is architecture? It's in a way art and science of designing. Or also we can say arrangement of elements involved in building something. It can be a building or it can be a software systems or it can be anything. More formal ways, it is a process and product of planning, designing, and constructing the buildings or other structure. That is what architecture is. Then what is data warehouse architecture? In a layman terms, it is a conceptualization of how data warehouse is built. So when you are building the data warehouse, you got to define the architecture. As a part of the architecture, how the communication is happening between the different components of the data warehouse and how we are presenting that to the customers of an enterprise. When we say communication, we're talking about a passing of data from one component to another component, because here the communication is movement of the data from one system to another system. So which are the systems involved and how the systems are communicating to each other in terms of data processing, and how are we presenting that to a end client? That is what is defined as a part of the data warehouse architecture. At a high level, in data warehouse architecture, we do find databases, we do find ETL tools, we do find metadata, we do find query tools, and we find data marts as well. We can look at the architecture in two different ways. More or less, they boil down to the same thing, but the way we are looking at is different. One way is based on the layers. The second way is based on number of tiers. Data warehouse architecture can be classified into three types based on the layers. One is architecture without staging area, another architecture with staging area. The next one is architecture with data mart. So in case of architecture without staging area, what will happen is we have the data sources, then the data is moved into the warehouse directly without having any intermediary storage. So in what cases it may happen? It may happen where there is no or very minimal transformations are involved between data sources and warehouse. In this case, there is no staging area. From sources, the data is directly loaded into warehouse with transformation or without transformation. And then the data from data warehouse would be used by the users for their analysis and reporting. The next type is architecture with staging area. Very simple here. Between the data sources and warehouse will have a staging area. That is the reason we call this as a architecture with staging area. Staging area is also called as landing zone. Here we use this for a intermediate storage. From here, the data is subjected to the transformation and loaded into the data warehouse. In staging area, there are some quality checks done and some of the staging operations are also performed. And also, once we have the data in staging area, the transformations are subsequently applied, then the data is loaded into the data warehouse. What happens with the architecture of the data mart? Very simple. In the earlier layer, if you see, there was no data mart. We had data sources, staging area, and warehouse. So in this architecture, we are also bringing in the data marts. What are data marts? Data marts are subset of data warehouse. And anyway, we'll see what are data marts as a part of our subsequent videos. In this architecture, we have data sources, staging area, warehouse, and also data marts. The data marts are created on top of the data warehouse to cater different function areas or geographies. Whenever you have a data marts, usually the users who want to create the report, they pull the data from data marts rather than pulling the data from warehouse. We do have data warehouse architecture based on number of tiers. Am I talking about a Dunlop tier here? Not really. We are talking about a tier of applications. Based on the number of tiers, we have three types of data warehouse architecture. One is single tier architecture. Second one is two tier architecture. The third one is three tier architecture. So what is happening in the single tier architecture? As the name indicates, we have a single tier here. So here there is no explicit component that separates the analytical and transactional processing. In a way, reporting tools are also attached to the data warehouse. That is why it is called as a single tier architecture. So here we want to minimize the amount of data stored. That is the reason we are not trying to establish a explicit separation between the transactional processing and the analytical processing. So here we want to remove the redundancy between the transactional processing and analytical processing. Though we have a single tier architecture, but it is hardly used in practice. Then coming to the two tier architecture. What is happening in two tier architecture? Here, first and foremost thing is there is a client and data source server. We have a client applications and we do have a data source. One more important aspect is we do have a data staging layer. Since we have a presentation layer running on a client and data is stored on a server called the second tier. That is the reason it is called as a two-tier architecture. In addition to client server machines, we do have a staging area where the data is stored in the staging area before it is transformed and moved to the data warehouse layer. If you see here, there is no intermediate application between the client, you can say client as a presentation, and the data warehouse layer. It is only client and server. The client being the presentation layer and the server where the data is stored is a data layer. In terms of advantages, two-tier architectures are easy to maintain. Modification of the stored data is easy, and obviously it will have disadvantages. Like to some extent, there is a performance issue. Performance will be degraded if the number of users accessing the data warehouse is more. It is also to some extent cost ineffective as compared to the three-tier architecture. So we have three-tier architecture where this whole getting the data, cleansing the data, storing the data in data warehouse, and then presenting the data to end users, or this whole process is divided into three tiers. One is bottom tier, the second one is middle tier, the third one is top tier. So in the three-tier architecture, functional process logic, data access, computer data storage, and user interface are developed and maintained as a three different platforms. So what is happening here is we have operational databases like RDBMS, Oracle, MySQL, or PostgreSQL, and we do have a external sources, and we have a data coming from some files. It is extracted, transformed, and loaded into the data warehouse. Depending upon the requirement, we do create the data marts. And we have a presentation layer where we have a front end tools. Between front end tool and the data, we have a one more tier called middle tier where we have a OLAP servers. Let us look at them one by one in bit more detail. In case of bottom tier, we have a data in the data warehouse servers. Obviously, the data warehouse is a relational database system. Here, the data is cleansed, transformed, and loaded into this layer by using ETL tools and backend tools. Then comes the middle tier. In the middle tier, there is a OLAP server. Why do we need to have a OLAP server here? What happens is if you have a data warehouse and the client or presentation layer is directly pulling the data from data warehouse, there may be some performance issues. Just to avoid that, we are introducing a middle tier with the OLAP servers, which can be implemented with the ROLAP or MOLAP. That way, for the presentation layer, we'll have a abstracted view of the database. That means how the data is stored and all those things, it doesn't matter to the front end tools. It will be abstracted because this arranges the data to make it more suitable for the users. When it is arranging the data to make it more suitable for the analysis, obviously the performance should be better. So in a way, it acts as a mediator between the end user and the data warehouse. So what is happening in the top tier? Here we have a front end client layer where we'll get a jazzy reports. Top tier is nothing but the tools and API that users connect to get the data from the data warehouse via OLAP. Those tools can be query tools, reporting tools, managed query tools, analysis tools, or data mining tools. What is data warehouse again? We learned data warehouse is subject oriented, integrated, non-volatile, and time variant collection of data to support management decisions. That is the data warehouse. If I ask you a question, how many data warehouses are there in an organization? Any thoughts here? Is it 100, 200, 300? No. Usually, any organizations would have one data warehouse for the whole organization. If the organization is too huge, you may have a couple of more data warehouses, but definitely the number is not in 2 digits because it doesn't make sense. Now that we understood we have one data warehouse as a part of the organization, how much of the data is there in a data warehouse? Is it one record, two record? Is it 100 records? We have millions and millions of records as a part of the data warehouse. Remember, we are trying to get the data from heterogeneous sources, subject that for transformation and load it. We'll definitely have millions and millions of records in data warehouse. So what it means is we do have millions of records which are belonging to the different subjects like sales, product, like account, policy. You will have data related to different subjects as a part of the data warehouse. But why are we creating the data warehouse? To take business decisions. In order to take business decisions, what will you do? You write SQL queries and try to subject the data for analysis. In the data warehouse, we understood we have sales data, products data, we have account data, policy data, claims data, customer data. If you want only sales data, then you write a query to retrieve the sales data. Then do you think it will take a fraction of a seconds to browse through all the millions of records and give you the sales data? No, it will take time. That is where we need the data mart. So what is data mart then? Data mart is a subset of the data warehouse and it is usually oriented to a specific business line or team or a subject. So data warehouse is a monolithic repository of the data involving multiple subjects, which is one in an organization. If I want a particular subject data, then that is where we'll extract the subset of the data pertinent to particular subjects and make data marts out of it. If I ask you a question, does everybody need to know everything as a part of the organization? Not really. By creating the data marts, we can control the access to the data for different individuals in an organization. It will help us to impose the access. The second thing is, as we already discussed, it will definitely reduce the amount of time taken to retrieve the data. It will enhance the performance. So data mart helps to enhance users response time due to reduction in the volume of the data. See, for example, this is a whole monolithic data. We are reducing the amount of data here, right? So that is the reason it will enhance the query performance. And as compared to the data warehouse, data marts are less expensive to store and help us to do the analysis faster. So that is what is data mart is. Then we have learned about the data warehouse. We have learned about the data mart. How are they different? Let us look at the different dimensions in terms of differences. Here, in terms of scope, data warehouse is a centralized, possibly enterprise-wide system. It doesn't matter which application. So we have only one data warehouse, and definitely in order to build the data warehouse, it is a planned effort. We may plan for a year or two. On the other hand, data mart is a decentralized by a user area. It is definitely, there'll not be only one data mart for an whole organization, and it is specific to the decision support system. We may not plan the data mart in the beginning itself. Organically, depending upon which data is being queried more, will create the data marts. In terms of data, in data warehouse, we'll have a historical data, that is past data, and it is detailed and it is summarized. In data warehouse, data is lightly denormalized. On the other hand, data mart, the data is highly denormalized. What does it mean? We'll try to have all the data in one table as much as possible by minimizing the number of tables. And the data mart has definitely a history as compared to the data warehouse, and it is less detailed as compared to the data warehouse. In terms of subjects, data warehouse will have multiple subjects we already discussed, like product, sales, accounts, like that. But data mart will take one of that and we'll make a data mart out of it. It's like a one central subject of a interest for the users. How about other characteristics? Data warehouse is flexible, means we can dump any kind of a data here. Data mart, since we have gone to create the data mart which is pertinent to only subject, it is restrictive. It is data oriented and it is project oriented. Data warehouses, once you create, will last for 10 years, 20 years, but data mart will have a short life. It is large as compared to the data mart, and it is a single monolithic complex structure. On the other hand, it is multiple structures and it may become together complex. We have learned the database, right? How do we store the data in a database? Very fundamental, trivial question, right? We store the data in a database in form of tables. The tables would have columns and also records. Then how do we store the data in a data warehouse? Aren't you wondering? Because we are saying database is for transactional processing, data warehouse is for analytical processing. The way we store the data in data warehouse, is it very different from databases? Not much. In data warehouse also, we store the data in tables. As data warehouse is a large repository to store the data in structured format. In that case, we are storing the data in database in tables. We are storing the data in data warehouse also as tables. Then how are they different? In case of data warehouse, we store the data in tables, but we do have two types of tables at a high level. We have a table called dimension table and fact table. So we store the data in data warehouse in tables, but in data warehouse, we do have two types of tables in which we store the data. Data warehouses are built using dimensional data models which consist of fact and dimension tables. Fact and dimension tables are the basic building blocks in data warehouse. The data warehouse is built out of dimension and fact tables, and data warehouses are focused on dimensional modeling. What do you mean by dimensional modeling? At the end of the day, the data warehouse uses the dimensions and facts to store the data. That is what is called as a dimensional modeling. Let us understand the dimension and fact tables in a bit more detail. If you take any business for that matter, in a business, if you go and buy something, you'll say $10 or 100 rupees, right? This is a fact. The entities that are numeric are called as facts. This is a fact because they're numeric. The reason we call them as a fact, once entry is made in a table, you cannot change them. On the other hand, we have a descriptive entity which will describe the facts. They are called as dimensions. So facts are the numeric values and descriptive entities are the ones which will explain the business numbers. They're called as the dimensions. So what is a fact table? A fact is a quantitative piece of information about business processes. We can also call it as a measurement or a matrix. In case of database, fact table is the central table in a schema and they are connected to the dimensions. The fact table is a primary table in a dimensional model. What does it contain? Which we are repeating again and again. They contain the measurements or facts. And also they have a foreign key to the dimension table. Otherwise, how can we connect the two tables, right? They do have a foreign key to the dimension table. So most of the analysis definitely use fact table for their analysis and reporting. In terms of loading, whenever you are creating the database or building a database, first the dimension tables are loaded. Post to that, fact tables are loaded into the data warehouse. So what is the dimension table? Dimension table is a table that stores the attributes or dimensions that describe the objects in a fact table, which we have already seen earlier. So dimension table is a table which provides the perspectives for the users to view the business numbers. Let us say you are shopping in a retail shop or Amazon or any e-commerce website. When you go ahead and purchase some product, what and all will be there as a part of the product? First thing is, you'll have a date on which you have purchased. Then you have a store in which you have purchased. Then you have a product which you have purchased. It can be a dress, it can be a coffee, it can be a grocery, it can be anything. The product can be anything. So how much of the quantity of that product you purchase, that will be another attribute. And what is the price at which you are purchasing that product is also one more important information. Then what is the amount you have spent to purchase the different products? So that is also one more important information, right? And also the transaction number is also one of the important attribute. So now while I am explaining all this thing to you, you may be wondering, all this data is there as a part of one of your transactional processing system as one of the RDBMS database. But what is it we are trying to do here? We are trying to create a data warehouse. When you are trying to create the data warehouse, we cannot really have all this data dumped into one table, right? That is where we are storing the data either as a part of the dimension table or a fact table in data warehouse. So, but the problem here is I have all this data as a part of one table. How can I put some of the data into the dimension table? How can I transfer some of the data into fact table? That is where we need to have a sense of what are the attributes which fall under the dimension table. What are the attributes which can be loaded to fact table? The usual high level thumb rule is whichever the data which is of text data can be a dimension. Whichever the data which is numeric, that can be a part of a fact table. Why is that? As we already understood, fact table has facts and measurements. All these numeric values are facts and measurements, right? Quantity. Once you mention how many quantities you have purchased, that is never going to change. Unit price at that point of time is not going to change. Whatever the numeric data which was captured on that particular day is never ever going to change. That is the reason it is a fact. So most of the numerical values can be considered to be moved to the fact table. So at a high level, we understood how can we classify the data from transactional processing to be moved into dimension table to be moved into fact table. Awesome. Let us extend this further. So here if you see, we have the same data we are representing in a table. So we have a text data, we have a numerical data, that is number. So wherever the data is numerical, that we can consider as a fact. Wherever the data is descriptive, that can be considered as a dimension. If you see here 10, 20, 30, 100, 120, 20, these are the facts, okay, are the measurements. we're considering them to be moved to the fact table. Now, what exactly is a dimension? Dimension will describe these quantitative numbers. Now, can you imagine a quantity without a store and a product? You cannot. In order for the quantity to exist, you have to have a store and product. Otherwise, this quantity and unit price will not have any significance. So, dimension are describing this quantitative numbers. So, we can establish a relationship by store to the quantity. So, now the whole data is there as a part of any RDBMS database. Based on whether it is a dimension data or a factual data, we are trying to move that into a dimension table or fact table. Now, once we move a certain number of columns into dimension table and certain number of columns into a fact table, you got to establish a relationship between these two, right? That is where we can establish a relationship between store to the quantity. I hope it is clear how we can categorize the data in a transactional processing table into dimension data and fact data. Let us extend this with a one more important example. You can see here there are 4 tables: customers, product, store, and state. What are these? These are dimension tables. Why are these dimension tables? We say product ID, it is describing the product. Customer it is describing the customers. Store it is describing the store. State it is describing the state. So in the center, we have a one more table called order. What kind of a table it is? No brainer, right? It is a fact table. So these are dimension 1, dimension 2, dimension 3, dimension 4. Why is this guy a fact table? Because you can see there is a order amount, order quantity. These are facts. These are measurements. So now what is happening here is we have a fact table with different attributes. Can we just have only fact table and start analyzing the things? We can't do that. We got to establish a relationship between this fact table and dimension tables. So what do we do here now is each of the tables should have a primary key. Like customers has a customer ID as a primary key, product has a product ID as a primary key. So the primary key of these individual dimension tables would become a foreign key of a fact table. That way, depending on the analysis what we are trying to do, we can always join the relevant tables and try to get our information. First of all, what is schema? You would have heard this term multiple times, right? So what is schema? Can you just recollect? Schema is a framework. What kind of a framework? It is an analytical framework that helps to organize and interpret the information. It's a generic definition of a schema. Schema is nothing but a framework that helps to organize and interpret the information. But when we come back to the data, schema related to the data defines how the data is organized and how the relations among the different sets of data are associated. Let us understand the schema and data warehouse. Before we really get there, what is schema in database? Database schema is nothing but a blueprint of a database which describes how the data relate to each other in different tables or in different data models. Then what is schema in data warehouse? It is just an extension of that. Data warehouse schema is a blueprint of how data will be stored and managed in a data warehouse. Again, we are talking about how are we storing the data? How are we managing the data which is there in the data warehouse? So that will be indicated by a data warehouse schema. One more way of looking at is data warehouse schema is nothing but an organization of how the data is stored and how it relates to other data within a data warehouse. If I ask you a fundamental question, how the data is stored in data warehouse? We already covered that as a part of our previous video. If you recollect, the data is stored as fact and dimension tables in data warehouse. And what did we understand as a data warehouse schema? Data warehouse schema is nothing but how the data is stored and it relates to the other data within the data warehouse. Now that we are saying data is stored in fact and dimension tables, data warehouse schema is nothing but how the fact and dimension tables are arranged. Based on how the fact and dimension tables are arranged, we have different types of schema in data warehouse, and they are, first and foremost, is star schema. The second one being snowflake schema. Third one is fact constellation schema. So what is star schema? You can see all stars. Are you thinking about a twinkle twinkle little star? Yeah, I can think about it, but we are talking about a star schema in data warehouse. Star schema is one of the fundamental schema where we have a single fact table surrounded by dimension tables. That is the star schema. So why do we call this as a star schema? If you look at the ER diagram, that is entity relationship diagram of this schema, it almost looks like a star, almost simulates a star with the fact table in the center and dimension tables around the fact table. In star schema, there is a 1 to n relationship between the fact and dimension tables. So each of the dimension table has a direct relationship with the fact table. With this, every dimensional table, its attributes will have a chance to participate in a query. In star schema, dimensional tables are denormalized. How come denormalization maximizes the performance? Because most of the data be in the same place. If you remember, if you normalize, you have multiple tables, table 1, table 2. When you denormalize, maybe the data of these 4 tables will be in the same table. That will help the query to get the data in less time. Because the data is denormalized, it is awesome for ad hoc queries. On the other hand, it may not work out for the transactional processing. The star schema is one of the simplest and most effective schema in a data warehouse. Let's take an example. If you look at this wonderful example where we have sales fact table in the center and dimension tables like product dimension, customer dimension, country dimension, and brand dimension are around the fact table, which looks like a star. Here, each of the dimension tables has a direct connection to the fact table. For example, product dimension table has a direct connection to the sales fact table with their product ID becoming a foreign key here. The same is the case in the customer dimension table. Customer ID, which is the primary key here, has become a foreign key in the case of fact tables. So that these attributes from a dimension table can participate in any of the queries submitted by users. What is snowflake schema then? Snowflake schema is an extension of a star schema where multiple dimension tables surround a fact table. Dimension table 1, dimension table 2, and all those things. What is the necessity to call it as a snowflake schema? That's because it almost resembles a snowflake. What is a snowflake? Are you planning to go to Shimla? If you are already there in Shimla, you are experiencing the snow, or you are in a windy city, Chicago. When it snows a lot, you'll feel like there are flakes, right? So that is what is the snowflake. Entity relationship diagram of this schema resembles snowflake. It's like a snowflake. That is the reason this schema is named as a snowflake. But have you wondered why it is resembling like a snowflake? If you just go ahead and deep dive, in case of snowflake schema, dimension tables are normalized. What happens if you normalize the data? If recollect, the number of tables would increase with the normalization of the data. When you are normalizing the dimension table, there'll be multiple dimension tables that will have additional tables. With that, the number of dimensional table would increase as compared to the star schema. And when we arrange all those dimensional tables around the fact tables, it looks like a snowflake. That is the reason it is called as a snowflake schema. Because we are normalizing the data here, we are storing the data in a less space as compared to the star schema. Because it needs less space, it is easy to maintain. Let us take an example here. In the center, fact table happens to be a sales fact table. So around sales fact table, we have product dimension, branch dimension, customer dimension, country dimension, region dimension, and also category dimension. There'll be many more dimension tables as compared to the star schema because we have done a normalization here. Let us understand the differences between the star schema and snowflake schema. In case of star schema, we'll have fact table and dimension tables. In case of snowflake schema, there may be a sub-dimension tables along with the dimension tables. As we already know, data is denormalized in star schema. But in case of snowflake schema, the data is normalized. Because the data is denormalized, that makes the data available in the same table or less number of tables. With that, amount of time taken to execute the query is less in star schema, but in case of snowflake schema, the amount of time to execute the query will be more because it has to go and join multiple tables. Because we are denormalizing the data here, we'll have a more redundant data in star schema, and since we are normalizing, there'll be less redundant data in snowflake schema. Because the number of tables are less, obviously the foreign keys will be less, and because the number of tables are more, snowflake schema would have more number of foreign keys. In case of star schema, because number of dimension tables are less, design would be simpler as compared to the snowflake schema. In snowflake schema, design is complex as compared to the star schema. What is this constellation? What is this fact? When you talk about the constellation, right? What comes to your mind? Multiple bright stars in a dark sky, right? In the same way, what happens in fact constellation schema in data warehouse will have multiple star schemas. Why does it happen? Because fact constellation schema is a collection of multiple fact tables having common dimension tables. How is it so different? You got to pay attention here. I'm not talking multiple dimension tables. I'm talking multiple fact tables, right? In the snowflake schema and star schema, I was talking about multiple dimension tables, but one fact table. In fact constellation schema, we're talking about the multiple fact tables. When you have multiple fact tables, obviously dimension tables are there around them, right? So fact constellation schema is a combination of several star schemas. Some people also call this as a galaxy schema. Because multiple fact tables are there, fact constellation schema allows the dimensional tables to be shared among different fact tables. As you have to use the data from multiple fact tables and multiple dimension tables, there is a need to connect between the multiple fact tables and dimension tables. As you know, it is a constellation. When you go to the constellation, it is complex. This schema is definitely more complex than star schema, snowflake schema. Why is it complex? Because of the multiple fact tables. When you have multiple fact tables, there will be multiple dimension tables surrounded by them. That adds to the complexity. Because it is complex to implement, to store, when you are writing the queries, you got to write the complex queries to access or analyze the data. Let us take an example here. We do have multiple dimension tables like customer dimension, product dimension, location dimension, and shipper dimension. Within these dimension tables, we do have couple of fact tables. Like one fact table is sales fact table, Another fact table is shipping fact table. How come this shipping fact table is a fact table? One of the reason could be whenever customer orders some products, everybody has to refer the shipping fact tables, right? That may be one of the possible reason where we have made the shipping as a fact table. Here you have multiple fact tables and multiple dimension tables. So for the representation, this itself can be a one star schema and this can be a star schema. So if you see, product dimension table is shared or connected to both sales fact table and shipping fact table. If I ask you a question, how do we store the data in data warehouse? In tables. And extending the question, whatever the data which is there in a data warehouse, will it change? Again, repeating the question. Will the data in a data warehouse change over a period of time? That is the question. Will you recollect the definition of the data warehouse? Definition says data warehouse is a subject-oriented, integrated, time-variant, non-volatile collection of the data. What exactly is a non-volatile? Non-volatile means not changing. So you got the answer for the earlier question, right? According to the definition of a data warehouse, the data is not changing. Hold on there. Again, the question is anything on this earth permanent? No, nothing is permanent. If nothing is permanent, do you expect the data in the data warehouse to remain non-volatile? When we said non-volatile, it is for a specific period of a time. As compared to the databases, in data warehouse, data is non-volatile. But it does change over a period of time. That is where slowly changing dimension come into picture. So when I say dimensions, I am referring to the data in a table of data warehouse. Dimensions in data warehouse contain a relatively static data. Static means which is not going to change, like locations, customers, or products. But as we discussed, those dimensions change slowly, unpredictably than following a regular schedule. That is where slowly changing dimensions come into play. So dimensions in the data warehouse are static, but they also change slowly and unpredictably. That is where slowly changing dimensions come into picture. So what is slowly changing dimension then? Slowly changing dimensions are the dimensions in which the data changes slowly rather than changing regularly on a timely basis. That is what slowly changing dimension is. All I'm trying to say is until now we are saying the data is non-volatile. The non-volatile as compared to the databases, but data does change in data warehouse. That is called as the slowly changing dimensions. Slowly changing dimensions are the dimensions in which the data changes slowly rather than regularly on a timely basis. Okay, we understood that data does change in data warehouse. But what are the repercussions of this? When I say repercussions, if the data is changing, is it good? Is it bad? Will that impact the performance of the data warehouse? Or will it impact the quality of the analysis what we are doing in a data warehouse? So what are the repercussions? If you recollect, we have fact table and dimension tables in data warehouse. If any of the dimension is changing, assuming that product is changing in a dimension table, some of the data in product ID is changing in the dimension table. Remember, this product ID is a foreign key in fact table. So it impacts the referential integrity. Means if the data is changing here, it impacts the data here as well. There'll be referential integrity problems. So how do we tackle these problems? To deal with such a problems, we follow SCD management methodologies referred to as type 0 through type 6 SCDs. So with the SCD, we store and manage both current and historical data over a period of time. Whenever you are building the data warehouse, you have to have a due considerations about the SCD. It is one of the critical ETL tasks in tracking the history of the dimension record. So SCD helps us to track the changes in dimension values, and it will also help us to report the historical data at any point of time. So this tracking and maintaining the historical data will be dealt through type 0 to type 6 SCDs. So we have type 0 SCD, which is a fixed dimension. We have type 1 SCD, where we are not maintaining the history. Type 2, we have a row versioning. Type 3, we have a new attribute. Type 4, we have a history table. And type 6 is an hybrid. What is your date of birth? It brings a smile on your face, isn't it? Look at this cute kid. So let us say your date of birth is 12/5/1996. Will your date of birth remain same, or it is going to change? Isn't it a silly question? Yes, it is. Date of birth will never ever change. Once you have born on the day, that will never ever change. Why am I talking about the date of birth here? That is where type 0 SCD comes into picture. What exactly is a type 0 SCD? It is a fixed dimension. What do I mean by that? Data in this dimension will never change. It is always original data. If the data is not changing, do you need to do anything to take care of this? No. That is the reason type 0 is a passive method. Since the data is not changing, nothing required to be done by yourself as a developer. So we call this ACD as a fixed dimension. Just to reiterate, in type 0, dimension attributes never change. As I said, one of the example is date of birth, and other example is sales transaction. Another example is join date. For example, you'll go and purchase a wonderful laptop bag for yourself. That happened to be a couple of years back. Let us say 21st November 2021. Will this change? No, you have purchased the laptop bag on this date. This sales transaction date is never going to change. Let us say you have joined the company on a particular date. Will that change? No. All these dimensions are never going to change. That is the reason it is called as a fixed dimension. Wonderful. That was fixed dimension. The next SCD is type 1. If I ask you a question, why are we talking about the SCD type 0, type 1, type 2? The answer is, if there is a change in the dimensions, we want to manage them. We want to tackle the changes. The referential integrity is taken care. So in type 1, the way we are tackling the SCD changes by replacing the old value with the new value. Here, what we are doing is we are overwriting the old value in a attribute, value in a table with the new date. Since we are overwriting, there is no track of the historical data. That is the reason we call type 1 SCD is of no history. It is tackling the changes, but without maintaining the history. Obviously, SCD type 1 is implemented only whenever there is no need to store the historical data. Let us take a couple of examples here. Assume you have a vendor table which has vendor key, vendor code, vendor name, and vendor state. Vendor state happens to be Karnataka. For a vendor, for some reason, he has to shift to another state, which is a neighboring state, that is Tamil Nadu. In that case, we have to take care of this change. How are we taking care of this change? By replacing the Karnataka with the Tamil Nadu TN. So how are we tackling the changes? By replacing the old value with the new value. Let us take another example here. Assuming that our employee Raju has joined in a US location. He really didn't like the US. So he shifted to UK. How are we tackling this change? By replacing USA with the UK, that is United Kingdom. That is how we are tackling the changes. But while we're tackling the changes, we are not maintaining the history. Let us look at what are the advantages of this type 1 SCD. Advantages are, in this case, maintenance is very easy because we are just replacing. the old value with the new value. There is no tracking of the history. Nothing need to be done extra. Because we are not adding any extra rows, the size of the data warehouse will remain same. As compared to the other ACDs, the size of the data warehouse will be less. One of the disadvantages is there is no historical data in the data warehouse. If I want to tackle what has happened in the previous vendor time and what was the earlier location of an employee, I don't have a data for that. In most of the cases, that is a disadvantage. What we are trying to do as a part of this type 0, type 1, type 2, type 3, type 4, type 6 SDDC is we are trying to see how to tackle the changes in the dimensions. So in type 0, it was fixed. Type 1, it was replacing the old data with the new data. In type 2, we are tackling the changes by tracking the historical data. How are we tracking the historical data? By creating the multiple records. This is the data before the change. After the change, we are tracking the historical data by creating the multiple records. In type 2 ACD, we tackle the slowly changing dimension by recording the history in different rows. There are different ways of tracking the changes in type 2 ACD. They are through versioning, through flagging, and also through effective date. Let us look at them one by one. How do we tackle in a versioning? Very simple. In versioning, a sequence number is used to represent the change. In the sequence number, the latest sequence number always represents the current row, in turn the current data. Previous sequence numbers represents the past data. Let us take an example here. If you see here, this is my earlier table, and in this case, the location of a employee is getting changed. How am I tackling this? By adding one more record. So in the record, I am tackling this by a version. This is the previous data where the employee was in US. This is the current. The latest sequence number represents the current data. Currently, Raju is in UK. This is how you tackle the change by versioning. And how do we do as a part of the flagging? In flagging method, a flag column will be used. The current record of the flag column will have the value as 1. It is the current data. All the previous records will have the flag as 0. Let us take an example here. The previous location before the change of the data, before Raju moved out of this location, the flag is 1 here. That means it's a current flag. Currently, Raju is staying in USA, but he shifted to UK. In that case, USA location flag is put to 0 and UK location is set to 1. One more way is effective date. In this case, the change is tracked using the start date and end date columns. Null value in the end date indicates the current version of the data and the remaining records indicate the past. Let us take an example here. This is the previous data where end date is null, means Raju is still staying in US. But when Raju shifts to UK, what happens is we'll mention the start date as 5th December 20th and 24th January 21st. Since he has shifted to UK, we have the end date as null. Means still Raju resides in this location. Let us look at all the 3 different ways now. One is versioning by using the version 1 or 2. The latest is indicated by the highest number in the version. Then we have a flagging. In flagging, 1 is the current data. In the effective date, whichever the has null is the current date. When I'm talking about the SCD, all I am trying to do is how do I tackle the changes? In type 3 ACD, we are trying to tackle the changes by adding a additional column. Means I want to retain the history by adding an additional column. When it comes to additional column, right, what happens is you can preserve only one value, not more than that. It preserves the limited history rather than the whole row. Since it preserves the limited history, we can use it only when changes are occurring finite number of times. If changes are occurring very frequently, this is not the type you should be using as a part of your data warehouse. So what are the advantages here? Because we are using only one column, there will not be any tremendous increase in the size of the data warehouse. And also, it allows us to keep some part of the history. What are the disadvantages? Will not be able to keep all the history because we are limiting to preserve the history by adding a column. Let's take an example here. We have an employee table with employee ID, employee name, employee designation, and employee salary. If you are part of any growing organization, salary will increase year on year. So the same thing happens in this organization also where we are taking the data. In case the salary increases, the way we are trying to track the changes is by adding a one more column called employee current salary. You can see here John's salary increased to $80,000 from $60,000. On the other hand, James' salary remains same. So that way, we are tracking the changes by adding a one more column called employee current salary. Then one more example being, do you think the designation of the employees will remain same forever? No, they do keep changing. In this case, John has become a team lead now. So the way we can do it is, you can say employee current designation is team lead, and with that salary also increasing. So we have, whenever there is a change, we'll add a new attribute to track the change. If you look at all these things in entirety, so this whole table has been changed into this table where employee current salary is there, and also we'll have the change here also where employee current designation is there. Why are we having a type 0 to type 6 SCDs? To track the changes in the dimensions. So history table, what is history? Are we going back to how Alexander conquered half of the world? No, we're talking about the dimensions here. We are talking about the data warehouse here. Whenever there are changes in the dimensions, we'll track the changes by creating the history table. So one table keeps the current data and another table is kept to record the changes. That is a history table. So in order to have the reference, surrogate keys are referenced in the fact table to enhance the query performance. So what are the advantages here? One wonderful advantage is we are separating, we are isolating the historical data from the current data. With that, what happens is, since the table having the current data is of small size, the query performance improves. On the other hand, obviously we have to maintain a lot of data. So with that, the administration and also size of the data warehouse also will increase. Let us take an example here. Here, if you see, we have an employee table. Here, John has been promoted to the senior developer. What should happen here? The current table is having a senior developer promoted as a team lead, but there is a change, right? We don't know what designation John had before he became the senior developer. So how do we track these changes? By using a historical table. So if you see here, what we are doing is designation earlier to senior developer is developer, then he was promoted to senior developer. Now he has been promoted to the team lead. So the current designation is team lead. This is how we are tracking the changes by maintaining the employee history table. One more example, if you say you have vendors, if the vendors change their state, we can create a vendor history table and maintain what was the previous state and what was the current state. We are saying hybrid. What kind of a hybrid we are talking here? Are we talking about any crop hybrid like maize hybrid or cotton hybrid? No, we're not talking about that. Then in that case, are we talking about hybrid of a car like petrol engine or electric motor, combine them to make a hybrid vehicle? No, we are talking about a type 6 SCD hybrid of what? It is a combination of type 1, type 2, type 3 SCDs to make it as a type 6. Since we are combining type 1, type 2 and type 3, we are calling it as a hybrid SCD. So then what is happening here? Let us understand this with an example. Whenever we have a table where the dimensions are changing, maybe senior developer may become a team lead or a salary may be increased, then the start date and end date also will reflect. In that case, we can use type 1, type 2 and type 3. What exactly is happening in type 1? In type 1, we are replacing the old value with the new value. In this case, we are replacing the senior developer with the team lead. In case of type 2, we are going with the row versioning. In this case, if you see, we have a flag. Wherever the flag is 1, that will be the current data. And also, we have the whole record here, which is introduced to track the changes. As a part of the type 3, what are we doing? We are having two columns, like we are also maintaining a current designation column. That is how the type 3 ACD works, right? We'll add a new attribute to track the changes. By using 1, we are replacing. By using 2, we are having a flag and row versioning. And by using type 3, we are adding a new attribute. Since we are using all three of them together, we call it as a hybrid SCD. Let's take one more example. In this case, we have a vendor table. So we have the vendor may change its state. So what we will do is we'll go ahead and have a flag yes or no. That is one. And the current state has been replaced by Tamil Nadu. That is TN. And also we have a one more current state column which is added to tackle the changes. We have type 1 which is a replacement, we have type 2 where we are maintaining the row versioning, and type 3 where we are adding a new attribute. Wonderful. We understood type 6 SCD, which is a hybrid of SCD1, SCD2 and SCD3. I hope you got how the changes are tracked and managed in data warehouse through SCD types. That is it, SCD type 0, 1, 2, 3, 4 and 6. Please remember all these things because this is very, very important in terms of data warehouse implementation. Before we really get into ETL tools, what is ETL? As we already know, ETL is a process of extraction, transformation, and load. Whenever you are building a data warehouse, you got to extract the data from multiple sources and subject that for transformation and load that into data warehouse. So ETL process is one of the very important process in any of the data engineering tasks. Now that we understood what is ETL, how does the workflow happens in ETL? Means, yes, we understood we have to extract the data from different sources. Source can be here, it can be RDBMS sources like Oracle, MySQL, PostgreSQL, so on and so forth. And we have to extract the data from applications. We have to get the data from files. And then after extracting, we'll subject the data for transformation. Then we load that into data warehouse. So for extracting the data, for transforming the data, for loading the data, something has to be done, right? Or it will happen automatically. Okay. If you say, hey God, can you please make ETL happen? No, it wouldn't work that way. You have to code in any of the programming language to extract the data, transform the data, and to load the data. So we can call them as a hand coded pipelines. Means you have coded to establish that pipeline where you're extracting, you're transforming, and you're loading the data. So what happens in an organization? You may go for a historical load or you may go for an incremental load. So in either case, if you have to write a code every time when the new source is added or there are some changes in the current source, then it becomes a humongous effort to go on customizing the code to extract the data, go on customizing the code, transform the data, go on customizing the code to load the data. That is when we need ETL tools. So ETL tools will help us to extract the data from different sources, transform the data, and load the data into data warehouse. So ETL tool will come with multiple functions to facilitate the ETL workflow. One beauty is all these ETL tools have graphical user interface. With that, it is very easy to do mapping of the tables from source to target, and also what kind of a transformation need to be done. All those processes become very easy with the ETL tools. Instead of coding on your own to do the process of ETL, it is always better to use the ETL tool to do the work of extraction, transformation, and loading. So what are those tools? We do have multiple tools. These days, one of the very important cloud-based ETL tool is Azure Data Factory. We do have other tools like Oracle, Informatica, Google Data Flow, MySQL Server Integration Services, Talent, and Apache Nifi. So these are the tools which will help your ETL process easy and less time consuming. Scheduling. What kind of a scheduling we are talking here, and why do we need that here? We understood in order to build the data warehouse, we need to go through ETL process. Either you can hand code the pipeline or you can use the ETL tools. So ETL tools will help us to extract, transform, and load. But if I ask you a question, will we be running data pipeline only once? Let us say you have built a data pipeline either through handcrafted code or through ETL tool. Will you be running the data pipeline only once during the entire time of data warehouse creation? No. You may have to run the pipeline multiple times. That is where scheduling tools will come into picture. What they do, they simulate so that pipeline runs on its own without the manual intervention. So if you schedule the tool, it has schedule this whole ETL need to be done at 12 o'clock in the morning. Then the scheduling tools will trigger the ETL pipeline and takes care of extraction, transformation, loading through the ETL tool. We have some of the scheduling tools like AutoSys. We have like Tidal. We have like Control M. These are some of the scheduling tools which we can think of and which are there available in the market. There may be some other also, but we're just introducing these three to you. So if you look at the AutoSys, it is used for defining, scheduling, and monitoring the jobs. Jobs being here ETL jobs. So the jobs is nothing but a ETL jobs, right? They can be either Unix script or a Java program or any other program which can be invoked from the shell. We do have Tidal, TES. What is TES? Tidal Enterprise Scheduler. Tidal is a scheduling tool with which we can schedule or run the jobs. So depending upon what the company and what the project requires for running the ETL pipelines, which also can be considered as a batch processing, TES comes handy to schedule and monitor the jobs. So what happens is TES, that is Tidal Enterprise Solution, will be sitting on the layer above the jobs which are used for ETL transformation, so that whole process of extraction, transformation, and loading can be taken care, like where exactly we have to run the flow and how, when, all those things will be taken care by Tidal. So why do we really need to use the scheduling tools? While you understood some of the important advantages, let us discuss them explicitly. So they're flexible. I mean, you'll be able to schedule the jobs at any point of time in the night or in the day. It doesn't matter. Obviously, since we are automating, once we said there is the manual intervention, right? So with that, it increases the organization productivity and they reduce the risk of system downtime, and obviously they are time saving and they do provide multiple operator functions. What is data warehouse? We understood data warehouse is a subject oriented, integrated, time variant, non-volatile collection of the data to support the management decision making processes. If I ask you a question, whatever the data warehouse you have built is used by whom? It can be a manager, it can be used by a vice president, or it can be used by a president. So if I ask you a question, will they have a time to write a SQL queries and extract the data? No, they wouldn't have so much of time. That is where we need to have reporting tools. So what are reporting tools? Reporting tools are a data reporting and data display software programs. We can also say these are the applications that provide enterprises with various reports about their businesses. Where is the report coming from? How are they building the report? By extracting the data from data warehouse. So, but the data is already there. Why do we need to extract the data? As I already indicated, the management people may not have a time to extract the data and put it in an Excel sheet and make a sense out of it. Instead of their writing a queries, you can have a reporting tools which will get the data from data warehouse and present it to the management team in a nice graphs. Based on that, they can take some decisions. As I said, we need reporting tools for the visualization of the data. How exactly the data is visualized? You got to visualize the data. If management teams or data analysts are the people who are trying to take some decisions, if you put the data in a proper format, they'll be able to make sense of the data at a faster pace. So reporting tool with their visualization will help the management team to visualize the data and find out where and how they can take the decisions. If you were to compile the reports manually, which we used to do earlier before reporting tools, it is a very cumbersome and tiresome process. So instead of that, go and take help of reporting tools. That way, you will be able to pull the better reports and visualize them in a nice manner and take the decision earliest. What are the benefits of the reporting tool? Which in a way we already discussed. It will speed up the reporting process. It will improve the decision making because you are getting a ready-made reports, and it makes easier for the analysis also. And it will also enhance the performance. Like instead of you writing a query, there are already some inbuilt queries. With a click of the button, if they're coming, it will enhance the performance. And we can also have reports will have a robust operating mechanisms, and it will also enhance the management systems like business processes and setting the goals. Right? It is very easy to use. We can drill down and drill up with the reports. We do have some reporting tools in the market, and they are Power BI, Tableau, and IBM Cognos. There are multiple reporting tools which are available in the market. We're just giving you the sample of them. So if you go to the Tableau is used for data analysis purposes, and it has inbuilt statistical functions, data trends, predictions, and forecasting. See, even though we say it is a reporting tool, we are extracting the data. We are getting the data from a data warehouse. On top of that, if you want to do analysis, Tableau provides all those functionalities to get the trends, to predict what is happening, and also forecasting mechanisms. If you want to get the multiple views of the same data, it is possible through Tableau. We do have a IBM Cognos. It is a business intelligence tool for web-based reporting and analytics. This is an enterprise software which provides the features to perform the data aggregation and to create the user-friendly reports for the management team. IBM Cognos has both on-premise application and also cloud-based application. You can use either the on-premise or cloud-based depending upon your requirement.
That's all for now. Like and subscribe and turn on notifications for future videos. Thank you.